listen-only mode.
And be sure to record.
So hi everyone, and thanks for joining this webinar. Today we're going to be showing you how you can leverage geodesign and use it to model for the future inside of Esri CityEngine. And we're taking the geodesign process and we're using the process to help to create smart 3D city models of what's there and also the future for our cities. So my name is Jeff Taylor, and I'm a 3D solutions engineer here at Esri. I support 3D specifically within the local government and geodesign sectors, and my background is within the areas of planning, landscape architecture, and urban design. And with me today, I'd like to introduce Shannon McElvaney.
Yep. Hi everybody. Thank you for joining the webinar. I'm the Community Development Manager at Esri, which covers urban and regional planning, economic development, sustainable development, things like that. I'm a professed geodesign evangelist, and I joined Esri to work on creating GIS software that enables people to design, build, and maintain livable, sustainable, healthy communities. And I'm joining Jeff today to talk about geodesign.
Thanks, Shannon. So let's dive straight in. And I want to show you guys where 3D GIS today, but through the use of case studies, successful implementations of CityEngine and Esri's 3D technology. So I want to start off with something that's very cutting edge. So we've been working with Singapore as part of a research and development partnership with their land authority. And we took a lot of their existing data, models that they already had, and then took building footprints and procedurally modeled those in 3D. So we used basically rules in CityEngine, codifying design, to create what's there. But we also leverage these rules to create how areas could look within certain places. So what you're seeing now is the Jurong Lake District. If you've ever been to Singapore, it's a really beautiful area. And that's that whole area modeled in 3D. So what you're also seeing are procedurally modeled buildings now. This is leveraging the geodesign process and also modeling how transit stations look within the island. So another example, use case, City of Rochester had a very successful CityEngine implementation. This was accomplished by a firm known as Bergman Associates. They have a really great background with 3D, and then they've been implementing CityEngine for the past several years. So what you're seeing here is a 2D master plan superimposed with existing 3D models from PLW ModelWorks Pictometry. And we also have existing 2D GIS data that was extruded into 3D, such as trees, streets, and other information. And then we have draped imagery on top of the terrain as well. And all this is exported to a web scene. So this means that you can share, communicate, and collaborate with other people online, internally, your own organization, or the general public based on your use cases. And you can even do public commenting, and we'll show you more of that later. But they could even take in some BIM models that they had. So these Revit models, they convert them to GIS or a Collada model, loaded them straight in, and you can visualize these buildings in 3D. And then you could also visualize other aspects of the downtown. So I'd really recommend, if you guys have a chance, Google the Bergman Associates Rochester, New York project, and you'll find some really neat things of how they've codified design as you see here. So these are taking these future plans, basically city standards for setbacks, for buildings, and how they should look, the form, and the character. And we were able to, Bergman was able to codify these within Esri's CityEngine's procedural rules. And what you're seeing here are how these proposed regulations or forms based on the land use types or the zoning, the form-based codes, will allow the city to be built in the future, or how it could look visually compared to the existing conditions. So CityEngine is great for designing the future as well as the existing conditions, as we've mentioned. It's also been used in the entertainment industry, and this is where a lot of the software started back in the days that it was just procedural. And this is the largest 3D city model that was ever created. And it's a large chunk of London in 3D, looking fairly accurate. So today we're going to go into the smart 3D city model creation process, both for the existing conditions a little bit and the geodesign part of things. So with 3D, there's challenges. Before, it wasn't easy. With procedural design, we're really breaking a lot of these barriers to the difficulty levels of modeling in 3D. We're automating a lot of these manual processes that are very painstaking and time-consuming. And this image shows the best representation of what procedural modeling is capable of doing. With traditional 3D, you have to model by hand, and it can take a while. But with procedural modeling, you just put a little more time up front customizing the rules that we've already developed, or you can code your own custom rules, or just use ones that we developed without having to customize them, and you can be successful with recreating a large area of your city in 3D. You can always go back later on and edit key buildings or key areas manually as needed, but for a lot of our needs with modeling cities, elements are very repetitive, and we can leverage these procedural rules to be successful. And it supports generation of multiple alternatives within the geographic environment, meaning that everything procedural is GIS driven in nature as well. It leverages your GIS data and attributes to create things in 3D, which makes it spatially enabled and more sustainable of an application to use for the design process. So CityEngine is smart. It works off of these common databases of rules, allowing for multiple views and performance reporting. So what you're seeing here would be looking at stormwater visualizations by the flip of a switch in CityEngine, or looking at the zoning regulations, the unseen environment, adding that fourth or third and a half dimension to our master plans that we want to showcase to try to get support and buy-in. The other thing that CityEngine can do is it supports the rapid generation of multiple scenarios. So there's alternative futures analysis of scenarios that you want to accomplish can be done leveraging CityEngine CAD data and even GIS data. So here's an example of a transit-oriented development in Honolulu, and you see a couple of options here. We receive engineering documents, and we're easily able to model these up, write some procedural rules for option number 1 to show what would the city look like if we limited sprawl. But also at the bottom from a GIS analysis where we were able to grow streets and emulate how that area would look if suburban sprawl continued at its current rate with this limitation. Now with option number 2, we see more suburban sprawl with a less dense core, and it just gives us a way to really visualize the futures through the modeling process. So with CityEngine, what you get is a complete 3D modeling suite. And the key to its success is in its procedural modeling core that allows for rapid creation of 3D cities. And when you move a street, a building, or some other element in CityEngine, all the geometries adapt to the changes. Street modeling tools enable anyone to quickly create streets by hand or from existing splines or network data. And also, since CityEngine is geolocation aware, everything you create or import into the system remembers the real-world coordinates and makes it easily interoperable with other geolocational systems. And with CityEngine, we showed you a brief overview of this earlier with the same Bergman project of Rochester, but we allow anyone to share their 3D models at the end as web scenes, or export them to a game engine, or export them to a rendering engine to create movies out of them as well. And with this, 3D is in the browser without any plugins. It's easy and free. And it's also embeddable. You can embed these within your own websites. We provide codes in there, and there's 3D commenting capabilities as well. As you see here, swiping between how it looks now and the future. Really valuable tools to help you within some of your workflows and disseminating information. So I want to briefly go into what's new in our next version of CityEngine before we start to go into the geodesign process to give you an idea of where we're moving. And CityEngine 2014 will be out soon. And with that, you get a robust rule library for more accurate building forms than we've ever created before, more accurate texturing, and the roof forms all built in, and these align to actual usages from GIS data. So it's tied to work with our 3D city information model, which is also our enterprise model for 3D. And I'll show you in a little while where you can access our past webinars where we actually go more in depth on that and the existing conditions city creation. The other great thing about CityEngine 2014 is it's the most stable release since Esri acquired Procedural, in that we completely rewrote the procedural core that's inside of CityEngine, so it'll run inside of ArcGIS as a geoprocessing tools, or as a software development kit, an SDK, within other third-party modeling software, such as, for instance, Maya. It could be SketchUp, or even game engines, such as Unity. And then now what we've also added is a support for courtyard creation, or holes within buildings, or donuts. This also supports the is-hole operations on GIS data, where holes may be in a vegetation layer or some other data layers. We now respect and don't scatter objects through where holes are within our GIS data. So I want to give you a quick overview of the new building rules. So if we select one of the buildings and manipulate some values here, we have added the ridge height capability into the building. And we can automatically switch between some specific usage types, such as office, commercial, it could be residential, whatever you want to choose. And then we can change the form of the building by using some of these preset settings as well. And you can always customize this rule if you want to program, but we recommend using it out of the box, and you can still be successful. So you can also change many of the roof forms, and these can even be leveraged from your existing 2D GIS data, your building footprints, and apply these rules to them as well to recreate a building more accurately than you could modeling it by hand in a short amount of time. So we can visualize the buildings in multiple ways, schematics on, different colors, with textures. We can change the unit types to the buildings. We can change the heights of the ground floor. Those adapt as every building has a different height for its ground floor, especially our older buildings within cities. And then we can change the way the patterns are driven as far as the geometric splitting of these patterns as you're seeing here, and color variations. So a couple other things that are great about these new CityEngine building rules. We can change any of these variables for the attributes or this information or the colors, and it gives us a new variation of the building. And what's also cool is that we can take and change or add our own imagery to these buildings in the case of the facades. So I could grab specific images that I've taken with a camera, load them into the facades folders or even the roofs folder, as long as they're formatted correctly, and they can be draped on top of your 3D buildings. So you can create your own library or modify our existing library to further adapt to your exact city. Now, not that this won't successfully help to recreate your city, but if you want that higher level of detail and realism, you may want to take a photo inventory. And as you see, you can adapt the height and other information, and the building moves to fit those standards. So next up, I'd like to introduce Shannon again to talk about exactly what geodesign is.
Yes, so I'd like to preface what geodesign is by the last slide that Jeff was just showing. I don't assume that everybody on the phone on this webinar is a GIS expert. So just to mention what GIS is here, the fact that you can take a map of all the features of on the planet of anything and separate them out into layers of information, and then use that information to help create models both of reality and what might be, what you're going to design and what the impact might be. All of these layers of reality can be used to do evaluation models that can run behind your design. And so I wanted to just mention that. You can collect, store, analyze, display, share information in a geographic way. Where on Earth is it, and how is it related to other things? So ArcGIS, in this instance, creates a platform for integrating both science and geography. And one of my favorite quotes from Jack is that GIS is becoming the nervous system of the planet. And he said that in 1995, which was quite visionary because it was far from that at the time. In many ways, GIS is becoming both the nervous system and the circulatory system and the skin and the skeleton of the planet. and it's become a platform on which we can integrate both science and social systems. So into using maps as that common language to allow us to better understand what we're dealing with, how the world works, and consider its health. So based upon that context, GIS is evolving into something we've called geodesign, and it's a powerful concept that combines both design thinking with the science of geography. In many ways, geodesign is the evolution of GIS, but from a definition standpoint, it's an iterative design method that uses stakeholder input, geospatial modeling, impact simulations, and real-time feedback to facilitate holistic designs and smart decisions. These are some of the words that have been associated with geodesign. It's cross-disciplinary, it's cross-sectoral. Some people have called it informed design. Recently I've heard it called evidence-based design, and others might call it performance-based design. In a way, all of these are true. You can create alternative scenarios. You can build models that calculate the cumulative impact of those designs to look at whether they're good or bad. So it's not just designing in 0-0 space. It's actually designing on the Earth and getting real-time feedback of the impact of your design. So a good example of that is right here, where you can use CityEngine to do geodesign. And I just took a couple of parameters. When you define the issues of your project, you can then look at it. In this instance, I'm looking at walkability, which has become a big thing, and public health, its relationship to public health. So from a geodesign standpoint, you create the procedural rules, you create what you want to measure, and in this case I'm measuring walkability. So the first drawing on the far left just shows you a regular street, which is very unattractive. It's hot during the day, there's lots of air pollutants, there's nothing protecting pedestrians from cars, so it's unsafe. But if you just change a parameter and say, I want to add tree medians with trees onto this scene, and create some shade so it's more pleasant to walk down. People will walk more if it's the trees are separating people from cars. And so your walkability improves, and so does your health. And then the far one on the left, on the far right, I've added a median in the middle, and these are all just parameters within CityEngine where you can say, okay, let's put bikeways and a planted median. Now we've got more carbon sequestration, we've got cleaner air, it's safer, it's more pleasant, even more people walk and we lose weight. So that's kind of the concept of geodesign. Alternative designs based upon programmatic goals that you want to attain a safer environment, a healthier environment, and then you can actually play with the designs until you get it right. And you can do that collaboratively and come up with multiple designs. And it's being used by a lot of different companies. And so I've got an example up in the far left for Tohoku, Japan, where the entire city was wiped out by the tsunami a couple of years ago. And they're redesigning the village. That's actually what used to be there. And then they're looking at alternative plans for what should be there. And the master planning is another key example of how you can use CityEngine. And again, identifying issues that you want to design to, the constraints and opportunities, and then do alternative designs and plan. And then the far right there, modeling climate change. Kleinfelder is doing a great job of using CityEngine to look at inundation of sea level rise and what might that threaten and what should we modify in the environment to protect it. And all of that can be done in CityEngine. And then just to mention, CityEngine is also, it's a part of our ArcGIS platform. We just launched a Geo Planner for ArcGIS application. This is built for the web. It's cloud-based, so you don't need any software, actually. It gives you access to all of our base maps that we've got and all of our data layers we have from vegetation and landscape and climate and hydrology, and all of our demographic layers, hundreds and hundreds of layers and thousands of attributes. You can create a project, pull in your data, put it on top of data that you find from the city or the county that would help you with your design. Do your creation, evaluate it, then compare your alternative designs and export those, report on them, and then export them to use in another program. And so that's what we're doing right now. You're going to see a lot of movement in this in the next year. It's just got released, and I think I'm going to pass it back to Jeff to show you an example.
Awesome. Thanks, Shannon, for the intro and all the information on geodesign. So let's go into a quick demo on Geo Planner for ArcGIS. I want to show you very quickly a 2D to 3D workflow. You can actually export your geo database with your designs directly outside of the Geo Planner from ArcGIS application that's on the cloud to CityEngine and model in 3D very quickly. So let's open up Geo Planner for ArcGIS, and first thing you see is this wizard screen that shows you all the capabilities and the key elements of Geo Planner for ArcGIS: projecting your data, your assessments, your creation, and all the other elements of the geodesign process. So first of all, let's create a new project very quickly, and we can use existing templates that have already been created, or you can create your own template in ArcMap and then load that onto this application online, on ArcGIS Online. So let's create a new project, give it some tags and information, and there we go. So I want to zoom into an area that I've already modeled a little bit of in 3D in North Carolina. And we're going to zoom in to an area near where an old school is. And let's say that, for instance, we wanted to do a redevelopment project here. So we can set a bookmark where the site is and add this bookmark in. And this allows us to conduct the planning and design process on a 2D screen. This could be a tablet, it could be your laptop computer, or your desktop, whichever one you'd rather use. So we can do measurements within this interface, very quickly get estimation values for area and the size of our sites that we're going to be working on. So that's 21 acres just about, or 21 and a half. Then we can go and start to actually create some new scenarios and new models for how this parcel or this location should be redeveloped. And we can start by drawing a skeleton or a new street network, as you see here. And this is a street network just like you'd have within ArcGIS that you'd use for real streets. And we can even change between different base maps to draw off of. You can even load your own imagery or data sets and draw on top of those as well. Or load existing GIS data and use that in place of some of this information. So then you can start to draw in some building blocks. So this, for instance, could be either building blocks or subdivision areas for commercial neighborhood. So let's put a commercial building here. Let's also put in a general commercial building very quickly. And I know these are fairly crude, but I wanted to show you this in a quick manner. And then let's draw an area where we want to put residential buildings in. I'm just going to draw this shape very quickly. Here we go. Just double clicking. And there's several other drawing tools, but these are just some of the quickest approaches to drawing with this application. Now, as Shannon mentioned earlier, there's all sorts of analytics and other layers that can be brought in through your design process, but all we want to cover right now is the ability to conduct drafting in a cloud environment. And multiple people could actually draft on this within a group at once, as long as their ArcGIS Online account supports multiple people. Shannon and I, for instance, could be designing at the same time together on this master plan collaboratively, and then we can load all the data at once and transform it to 3D. So we've created a very quick schematic for how this would look, and we can actually visualize this percentage of those areas that are drawn that are specific variables. So for instance, open space versus commercial buildings and streets. we have those metrics as well. And those can be further enriched with other data sets. So we can even compare two master plans. In this case, it's just one, but that gives you an idea. We compare two real sites or a site that you want to duplicate with a new master plan at the same scale. It's very flexible. So then I can export this data to a geodatabase, download it, and then we can start to take this information into CityEngine. So I already have a model that I've created of this area very quickly in CityEngine, and if you watch the last webinar, we'll show you more where you can access that at. We'll show you how we created this model from LiDAR directly. So there were no building footprints or tree points, and they were all extracted from LiDAR and modeled procedurally. Very quick ways of creating existing conditions model for planning processes. So then we can load our data in from that project we were working on Geo Planner, and I can just align my streets to the terrain and quickly just visualize this in 3D from a sketch. And then I can also align my other shapes to the terrain. It's just the same approaches that we take with adding existing GIS data onto a terrain to create the existing conditions. You just use a simple align to terrain commands, and it aligns your features to the surface. And then from there you can apply procedural rules just by the flip of a switch, or conduct cut fill estimation, smooth out your terrains, do all of that adaptive processes to make things fit correctly, and then apply procedural rules. So we can switch a rule for a forest cover area for this park area or this green space to include trees or be more formal or natural in nature. And then we can even subdivide larger shapes that we've drawn in CityEngine. So if you have CAD data, you've drawn up some plans for maybe something that you want to have as a new district or new areas you want to parcelize, you can do that here, or you can draw streets and subdivide from those, as we'll show you later in the presentation. I can apply buildings to these, and then I can modify the form of these buildings, as you see here. So I could change the way they're set back to maybe some predefined transect functions, which if you know a little bit about new urbanism, you'll understand transects. Or you can choose your own setbacks for how far the building should be set back on these parcels, and the floor heights, and everything on the fly, and they adapt. And as we conduct these changes, we'll get reporting, and we'll touch base on that more and more throughout this presentation of exactly what the building could cost to build, or other performance metrics such as sustainability metrics for consumption. So I can also select my streets, drag and drop a rule file to the streets to create those procedurally in 3D. And then I can drag and drop a couple of other building construction rules to those other shapes very quickly here. And let's say that I wanted to use the footprint rule instead of the parcel rule, and you see very quickly, how we can visualize that plan in the third dimension and understand, is it sustainable or not? Does this work? And then we can go back into Geo Planner if we like that medium, or you can do further iterations in CityEngine and export this data to Geo Planner or back to ArcMap or a CAD software for further refinement. So enough of that application. Let's go into CityEngine directly. So I want to talk about modeling the environment with CityEngine. So for the training we're going through today, if you want to learn more about creating existing conditions, I recommend going to the CityEngine YouTube page, clicking on this webinar, creating a smart 3D city model from start to finish, and then I'll tell you almost everything you need to know about how you can be successful with creating existing conditions for an entire city. But it can also be leveraged for small areas of your city as well. So also check out the CityEngine resource page under the ArcGIS resources pages. And under more gallery posts, you can find the training that we're using today. First of all, we have this example Redlands redevelopment toolkit that we're showing. And then we also have rules for 3D vegetation with LumenRT models that will show you how you can create landscapes with those rules later in this webinar as well. So what I'm showing you now for the first time is a 3D model of Raleigh, North Carolina that we procedurally modeled in 3D working with the city. So we have third-party buildings for the downtown core from PLW ModelWorks. They're highly textured and have a high accuracy to their geometric forms. But where we didn't have building footprints, we could collect height information, roof slope information, roof type information directly from the LiDAR data sets and apply rules to the building footprints with those attributes from the LiDAR to regenerate how the city looks So this leverages authoritative data to help to recreate the existing conditions in a very quick amount of time. And a lot of cities worldwide have data for LiDAR, and it's growing drastically due to flood requirements, for disaster response requirements, or even looking at all sorts of other things within cities. And there's entire states now that have repositories of this that you can access potentially in your own city if it's within one of those states. So let's zoom into a specific area of the master plan. This is a lakeside area that's a conservation area that's also used for recreation. But with this site, you'll see in a second that it's still zoned residential on the sides of it. So we want to estimate and visualize how that would look if a developer came in and actually built up the whole area. Maybe not that we want to build it like this, but that we wanted to get an estimate of the cost and how it would look. And then we could do further iterations of following more sustainable guidelines. So let's go into planning and the urban design process. So once you've built the existing conditions, you can then conduct a model of how the site could look. And let's load in some data. So I brought in some streets that I can start to create parcels off of or continue to draw off of. These are from the city street data layers. We also have parcel data that we brought in from the city that we could use if we wanted to. And then land use, which honestly, in my opinion, is one of the most valuable data sets that we can really leverage here to help to figure out, okay, how does this place look based off of its current ordinances? So I'm going to select the land use layers and just bring them above the terrain for now and hide them. We'll go into this a little bit more in a second on why we're using this data set. And then I want to select an area of the downtown and apply a procedural rule to these streets that I've just brought in. All the buildings are already procedural in nature. So let's just make the streets 3D as well. So I'm just going to select some of the streets and then select all of them. And apply a procedural rule for street construction. And this is the Redlands Redevelopment Rule Package. It says Geodesign Tools, but all you have to do is rename these rules if you ever want to, or copy and paste them into your own projects. And it's going to slowly start to generate all the streets at once. And this is a pretty large area, so it may take a few minutes for a lot of geometries for streets. So we'll just hang on for a second as it generates. And there we go. So the streets are being generated on the fly based on the attributes that we already had. Now we didn't have width attributes for the streets, but those can be added and adjusted in CityEngine as well. So I want to focus on this area that we wanted to visualize how it would look if a developer were to build on pretty much the full extent of that residential land use area in relation to the conservation land. So I've enabled that land use type. I've codified their land use types to align to specific colors so I can visualize the land use thematically above the terrain. And I can even design through vector layers. You can also draw through raster layers as well to create new street layouts and other things. So this aligns with that geodesign process and even the McHargan layer caking concept that people in planning, urban design, and landscape architecture are aware of. So what I can do is then select the buildings, and you saw how the land use, we can see the thematics, but we can also view thematics for the usage types of the buildings just by switching just some switches on what we've already have in the environment. And that's really valuable in the planning process because we can actually figure out, okay, exactly how are the places being used. So with everything turned on, let's change our view to a top view here. And I'm going to zoom over to the top of our master plan. And I'm going to start to draw some street networks. So first of all, we want to create our skeleton to create parcels off of. And you can generate parcels off of these street networks that you create. So I don't want to run it right up to the boundary of the conservation land, but what we do want to do is leave some spacing so we can either put houses on the edge of it or vegetation as a buffer between the neighborhoods and what's being proposed or the existing conditions. And then let's continue to draw the street network. throughout this entire area. And just connect it. So there's a few next steps that we want to do here. So I want to turn off the land use because we've already pretty much drawn our boundaries or our development within that area. And we want to subdivide the interior of these parcels. So what I'm going to do is select this interior line from the street networks in a second. Actually, no, let's actually further refine our street widths and other information before we subdivide the parcels and go through that process. So let's create a sidewalk width on the left side that's maybe 2.5 meters, sidewalk width on the right that's 2.5 meters, and make the street width about 10 meters or so. So by changing those values, the street widths adapt to the changes, and then we can go in and edit the procedural rules for the streets. So if I zoom in, you can see how the streets are being created. So Shannon did a great example, or showed a great slide with different street iterations earlier on. And we're going to go through the process of how you can create those multiple iterations right now. So I can change the character, the way this district of the city looks as far as the sidewalks go, and make it a red brick paver type instead of the concrete sidewalk. And I can change the scaling of that as well. We can add parking to one side of the road, so let's say maybe parallel or nosed in. So try nose in first, but since this is a residential neighborhood, we probably want to limit it to parallel so that we can have 2 lanes and it still works. And then turn off pervious parking, and we're going to get reporting on all this stuff so we know how large of the areas are for pervious parking, the sidewalks. If we have a median in those areas, we know the number of trees that we place on the streets procedurally, and all that gets reported in our reporting, as you see here. So we can then change the tree to a fan or a model representation and visualize those reports for that whole street network that we just created, and typically even add cost estimates to those. Those can be exported to Excel or other applications for further estimation. And then we could change even the tree types. So we'll select one specific tree type and everything looks relative to that tree. And turn on traffic lights, people, cars, other elements of the streets to add more realism for your design. So a 3D model without lifelike elements doesn't sell as well to the client. So let's go and visualize these changes a little bit further, closer up, that we just added to the street networks. And you can see there's the people, there are the trees, there's the cars, and everything is placed procedurally along this network. And there you go. Just really quickly visualizing that on the fly. So now that we've created the street networks, the next step we want to do, take a step back a second ago. We were going to subdivide parcels. Let's do that now. So I'm going to select the center lines between where the street networks exist. So let's turn off the shapes and just select the center line. I'm going to turn on the parcel subdivision capability here. Turn the parcels back on. And I can switch this to skeleton subdivision, whatever subdivision that's preset here that you like. Since this is going to be more of a suburban sprawl emulation, we want to make it look this way. And then we want to change the lot area to maybe 200, and you can see how setting minimums for lot areas allows you to have your shapes adapt to ensure that they all meet these minimum requirements. So you can keep fiddling with these around a little while until you get the exact forms that you want for your development based off of the size and area of the original start geometry. So then if you move a street network, everything adapts to the changes as you see. It's kind of how CityEngine works. We mentioned that earlier. And I can continue to even subdivide within these street networks with new roads, and the parcels adapt. So I want to select all objects in the same group, and then I want to apply a procedural rule to them for creating buildings. So let's use our building construction rule and the Redlands redevelopment tools that I showed you earlier. And it's going to start off by giving us a 3D zoning volume. And what this means is we can encode or codify the full volumetric limit that the building is going to be placed within on the site to try to preserve visual character or other sorts of character of that area and keep it within certain ordinances. This can be handed off to architects to make sure that they build within the specific volumes as well for cities, because there are sometimes issues with that in master plans and checking master plans. So we can change the setbacks for these volumes, and we can change the height tapers, all sorts of things. These can be used in urban dense areas or in suburban areas, as you see here. And then let's change the side setbacks. You see, you get the point. It all adapts to these changes as you move through these different volumes. So let's visualize the buildings with the zoning volumes just to see, okay, how does it fit? And then we can adapt the buildings to adjust automatically to the zoning volumes. And we're going to be working more and more to make sure the volumes of the buildings do fit within these 3D zoning forms as well, further with these rules. So then we can switch to just a building view, and let's go down here. We can actually start to visualize some of the reporting or these key performance indicators. These tie in with the LEED neighborhood standards as well for our baselines and cut and fill estimates and other things. So what I'm going to show you now are how to tie in the cut and fill estimation, so I can get a cut and fill volume and bring the terrain up to the bottoms of all these new geometries in this development, and then I can connect to those attributes for the cut and fill on those shapes that we've drawn procedurally. And you see there they're connected automatically. Regenerate the models, and we automatically get this rough estimate of what the cut and fill is going to be for the entire development. Now every footprint would also have its specific cut and fill value as well added to it. It's not complete engineering cut and fill, but it really helps with those preliminary design processes when you want to determine, is this sustainable or not? Can we afford to move this much ground? So let's turn on the building construction rule now. Let's modify the building forms so we can change how the geometry is as far as its form here by making it alternate, increasing, decreasing in nature. We can change the shape of the building to an L, U shape, different forms, an O shape even, or just to fill the entire area of the master plan or that parcel. And other things that we can do, change the layout orientation and other things, and then we can switch to a different visual. We're going to do that here in a second. So under the facade construction, let's just turn on the facades, and you can quickly visualize how those buildings would look. And that's going to add more metrics because there's more geometries being created on the buildings, which give us further reporting for window area or wall area, surface area, floor area ratios that are more accurate, number of windows, number of anything on the building could be reported. And that's the value of procedural modeling. Any element that you model and with a rule can be reported on and has intelligence. So we've ran some iterations. We've even changed the texture styles of the buildings using the rules, and they adapt all at once to these changes. You can even select certain buildings at once or by themselves or in groups and change these parameters to further refine the buildings to give them more character. So let's go through just a few other iterations and some changes on the facades, and then we'll go forward with the next portion of the presentation. So we can switch the roof types. We can even change that to a flat roof and enable solar panels even on the top of the roof. So just turning them on and it generates those, and those are actually added into the reporting so we can get report cost estimates of if the maximum area of these roofs before they were built were to all have solar panels and be flat, this is what it could cost, or you could do sloped roofs as well. And you can change the directions, how often they're spaced, and all sorts of other things, and even the cost estimates of these panels yourself, and get rough estimates on total amounts. So let's go back to a gable roof and continue on with the presentation. So what you've seen very quickly is the creation of existing conditions model for a new development, well, existing condition and a new development. And what we're going to go into next are some landscape type tools. So I'm selecting these buildings. And I'm going to drag and drop a green space construction rule directly to these parcels. And with this, we also get estimation on the green spaces as well. Just as with any other rules in CityEngine, we can switch between a natural or a formal landscape here. So if I select these elements before I change these values, it'll let me change parameters on how these shapes look. So let's reselect them and switch that to a formal landscape. And you can add more items to these. You can add people, trees, all sorts of other variables or other elements of the rule. Turn those on and they'll show up on the fly. So let's say that I wanted to put trees in here. I can select a specific tree. Let's go down and choose the European hornbeam, just like we have throughout other parts of the development. And I can switch to view how I want to view this, this tree as well. I can even add percentage of people, just like we did the sidewalks here. And it's going to scatter them. They're really small. And let's choose the percentage of trees. It's just a little bit lower down here. There's tree height. Oh, there's the percentage of trees. And just say what percentage of the area we want to have covered with vegetation. So 45% is too much. 20% looks fairly decent. So let's go with that, or maybe even 10. And it's going to scatter trees and give us real-time estimates on the number of trees that were scattered in that area and that total surface area. So that's using the very quick, rapid planning tools that we've developed for CityEngine to create new developments and even visualize suburban sprawl in alternative futures analysis as well. So I want to go on to the next portion of this presentation, which is landscape design. So if you go to the CityEngine resource page where I mentioned earlier, you can find this same toolkit. This is the 3D vegetation with LumenRT models rule package that you can download here. And you can load this directly into CityEngine and start to create landscape designs. So this is a partnership that we have with LumenRT, which is Eon Software. They're the experts on immersive nature, and they have a game engine called LumenRT, pretty much that allows you to load your models from SketchUp, 3ds Max, Revit, CityEngine, other platforms directly into a real-time engine to visualize these models. And they can even animate cars and people as well from the procedural rules. And with this rule set, you get a lot of different kinds of genus species. So all of these trees were created by Eon Software, which are the experts on digital nature. And they've done some really good movies such as Pirates of the Caribbean and other ones for creating the environments. And a lot of these trees are some of the same concepts or core capabilities of their technology that you see within our new landscape rules. So we're going to start by showing you some of the capabilities of scattering vegetation. So we could scatter one plant at a time. We could scatter orchids and roses, or multiple types of plants at a time. We can even choose densities, and they're all going to scatter differently here. So you can even have overgrown. And this can also be valuable if you're making video games. You can export the locations of each types of trees that you've scattered as points and link that back to a proxy in your game that you're representing over and over again. And then we have the ability to scatter ground cover as well. We have fountain rules, we have bench rules, 3D, other elements of the urban landscape rules that you can also apply into your landscape plans. So that's kind of one example. The next capability that we have for these plants is that we have the genus and species, the common names, and then we just use the genus if no species is matched. And you can kind of get other ideas here of how these work. We also support proxy models, so we have some proxy representations of trees. So that means that one tree can be called to and scattered 1 million times, and it only respects the one tree and the size of RAM that's being used in your computer. So we can represent the model in different ways. A low level of detail as a fan, a high level of detail as the high quality 3D tree from LumenRT, or even the analytical model for line-of-sight analysis. And we can link raster layer analysis to these trees. We could link other sorts of data to these vegetations to visualize that third and a half or fourth dimension of the environment in analytics and 3D within CityEngine, and even within ArcGIS moving forward with geoprocessing tools. So I'm going to download this project and load it into CityEngine. And I've went ahead and brought in a DXF file or a CAD file for a master plan for a landscape. You could also draw these master plans inside of CityEngine as well. It just depends on what your workflow is. But this adds a lot more value to those master plans that landscape architects are developing on a daily basis, because all you can do is you can just drag and drop rules and visualize and see, does this truly fit within my design guidelines or my goals that the client wants? So we can just easily import DXF files, CAD files in this way, and then it shows up within the viewport. So then I can select some of the trees, and I can just drag and drop a rule to these CAD circles where the trees are and generate them, and we're going to see trees generating on the fly within the centroid of that tree circle. And it's going to also help to give us some more realism by putting mulch at the base of these trees. So then I went ahead and applied other rules to other areas of the model, and I'm just going to generate it in 3D. And let's turn it to a different view where we don't see the wireframe. Now what you're going to notice is that this was actually drawn in feet and not metric. So all I have to do is go into the rules. I'm going to select all the plants and everything in this scene and just change the units from feet to meters. And let's regenerate this model here in a second, and everything will adapt. So the trees have changed, the hardscapes and the ground cover has changed a little bit on the way that it's scaled, and everything adapts to the correct coordinates or the correct feet or metric system, whatever you're using in your project. So what if I wanted to make some changes to this CAD plan? Well, you could do that. You can make changes to the geometries and even export them back out as CAD. You can even draw new areas and continue to develop your master plan that you may have already developed inside of CityEngine as well. In the long term, we hope that Geo Planner will be able to support these same sorts of 2D plans as well in a tablet-based environment, and then take them back and forth to CityEngine as another medium. So I can select the shape that I've just drawn, apply some procedural rules to it, and then I can change some of the different weight mixes, how the mixes are represented here. So we have 30% orchids, we have 50% of another tree species, and then maybe 20% of some other tree species. And then I can just go and choose my trees that I want to scatter. Scroll way down. I can even select multiple shapes at once and adapt these rules to multiple areas if I have the same types of mixes that I want to scatter in multiple areas. And then we can change how dense these ground covers are. Natural, sparse, dense, or even overgrown. And it uses different algorithms to tell us how it wants to place these. And we get reports on the number of trees and different things here. And you can codify other elements that you want or other reports that you may want for landscapes within these rules as well, as all these elements can be reported. So we can switch between an analytical model, which allows us to do 3D analysis for shadows cast in a new park or against buildings. We can switch to the fan representation as a lightweight representation, and even add ground cover to the area and change how it's rotated, the scaling of it, and other elements. So some other key pieces I wanted to show you very quickly that you can also leverage in CityEngine is the ability to take in third-party model assets. So you can take in some SketchUp models as object files or collada or other models that you may already have for people or buildings or other furniture elements, and apply them procedurally in here. So things that you've already built in your libraries of assets, if you're a 3D modeler or an architect, don't have to just disappear. You can still use those in CityEngine if you want to use CityEngine for your workflow. We can also draw shapes apply procedural rules to these, and let's say that I wanted to move the shape over here. I want to place that person on that shape instead, or somebody on a bike, and I can just drag and drop a rule for inserting an object on a shape. It's pretty much the same way that we just applied a rule to a tree. And that shape can just be turned off when you export the models out to another third-party modeling program or to a web scene, and you just see the person or the other asset within your urban design plan. So let's change the model. Very quickly and easy to do, and it adapts to those changes. You can change the rotations, where it's placed, amongst other things here on the fly. Okay, so we've shown you how to place assets within here that are third-party models, how to create existing conditions areas. Let's go through some of the procedural rules that we have for benches and the fountains as well. So we've written a rule that's very simple for a bench, and you can modify some of the thickness or the bench color, or even edit this rule and make the bench more detailed. You can add textures to it if you wanted to. And we have help files that show you how to customize things as well within CityEngine. And then you can change the colors, and all those variables adapt to the changes on the fly. So let's say that we wanted a bright green bench in this park to keep people awake, and there it is. So let's zoom over to this fountain, and I can very easily change some colors. Let's make it a children's pool. No, maybe we don't want that color, but let's change the colors on the outside. Everything adapts, and we can then change the ledge widths, and they all adapt on the fly as well, just like the parcels and the buildings adapted to the changes. So rules can be written for almost any geometry and have it model in the way that you'd like it to model. So I can easily export this into a web scene, right out of CityEngine, file, export to a web scene, and you can load it in, as you see here, and people can click on items, they get reports, they can view metrics, you can type cost metrics into here, you get area metrics, and they can add commenting, as I'll show you here in a second. So directly where I'm looking in the viewer, you're going to see a sunlight study. So we can actually, anyone can conduct shadow analysis on a new proposed plan, or even existing conditions of a plan. And we notice that there's not enough sunlight being blocked here throughout the day, specifically for summer months in this master plan. So I can move the plan to the specific view where the comment I want to put in here shows up, and I can add a comment. And this comment could say, let's say needs more shade for this landscape plan. And let's publish it, and it's automatically going to end up online, on ArcGIS Online, where we've hosted this model, and either your team that's building your new development in 3D, maybe it's a landscape plan, or even your client can leave feedback in the browser as to what he'd like changed, so these change orders. And this really helps to make sure that you mitigate any issues before the final result of the project, so that the client knows exactly what they're getting, and they can tell you, what they do and don't like. And then you can embed this within websites as well. So you have multiple case studies of projects you've built in the past, showcased as 3D models, and allow people to move through them interactively. So how do we export these to a web scene? Well, it's very easy. Just go to File and Export. So File, Export. Select CityEngine Web Scene, and I'm going to change the name. And then I'm just going to select all the layers and export them all at once. I could even select layers to swipe between, maybe a new plan, multiple iterations of a plan, and visualize those on the fly. So today you learned a lot about how Esri is taking your GIS to the new dimension, but also bridging planning and urban design within the GIS spectrum, and adding this geospatial coordinate to things so that architects think about things more instead of just focusing on fixity. And we give new tools to really help build more sustainable environments. So if you like some of the things that you saw today, we have a 3D jumpstart that we can send someone out on site for a few days and help to train you up in person. And you can contact our professional services team if you're interested in that. We also have other 3D city modeling capabilities in our professional service teams that can help you with this sort of stuff. Some of the business partners that we've mentioned today briefly were PLW ModelWorks. They're a 3D model provider. Bergman Associates built the Rochester Master Plan. They're a great team of architects, planners, engineers out of New York, but they also do work throughout the southeast and northeast United States, I believe other places domestically in the United States. And then Critigen is our large systems integrator, third party for Esri. And they have a 3D Jumpstart as well. I'd really recommend checking that out as they can help you with moving forward with CityEngine as well. And if you are interested in creating your city in 3D today, definitely go and visit esri.com/CityEngine and download the free 30-day trial. Let me know what you think about it. If there's something you have difficulty with, or some of the rules that you're trying out don't really adapt to what you want to accomplish, let us know, because you help us to develop the future of these tools, and we want to make sure that you're successful in whatever you do. And again, thank you for attending this webinar. On behalf of Shannon and everyone at Esri, we're glad that you had the chance to join and learn about geodesign and how CityEngine can help out. I guess at this point I'd like to open for questions. If anybody has any questions about what you've seen today, feel free to add those into the questions panel, and we'll go ahead and start to answer some of those. So I see about 4 or 5 questions. Let's go ahead and answer these, and as you have other questions, we'll be around for another 10 minutes or so to answer any questions you may have. So Vipul, I think this is India, is there any way to input coordinates to create geometry? And right now there are some ways that you can import certain coordinates, but it's not as adaptive as other modeling programs are. It's more of a tracing type capability inside of CityEngine for these geometries. But you can load in your GIS data and CAD data that you draw in other applications fairly easily. Next question, is Geo Planner for free for use, or should we have a paid account? I think Shannon could probably answer this the best if you're still online, Shannon.
Yeah, it's you do have to have a paid account. It runs on top of ArcGIS Online, and then it's a premium app that you purchase to run basically using the ArcGIS Online platform. It's available on the marketplace, the Esri marketplace. You can look at the details there. Just go to esri.com and go to the marketplace and type in Geo Planner, and you'll find a bunch of information about it. And it also has a 30-day free evaluation, so you could try that out if you have a ArcGIS Online organizational account.
Cool, cool. You can also find that on the Esri marketplace as well. I mean, it's all over the internet. Just Google Geo Planner, and you'll see a lot of reviews and information on. We just launched it not long ago, so we're really excited to see where this goes as a product. So another question we have, in CityEngine 2013, I can export to geodatabases for each feature, but in 2012, it exists, but it does not exist in 2013. Right now you can't export shapefiles back out, but you can export multi-patch files out to the geodatabase, and you can use the multi-patch to footprint tool to recreate the existing footprints of those buildings. But we're working on getting that added back into the next release of CityEngine, hopefully. So
it's a 2 or 3 step process, but so you can
right.
still get the stuff out.
And yeah, let us know this feedback that you guys have working with the software. If there's something in there that's really slowing down your workflows, or some features that you really need, we'd like to try to implement those if possible. So do you have any rules pertaining to utility networks such as water, electric, or something in the future plans? I don't want to speak much on electric because it's kind of a hack in the CityEngine, but there is a Middle Eastern rule set on the Resource Center that contains a power line. So you can actually model power lines procedurally off of street networks. So that is valuable, and yes, you can make them look fairly realistic. And I know that Elliot Hartley, who's on the line here as well joining this presentation, has done a great job with Garsdale Design out of the UK. Visit geoplanet.it, and you can view some of the electrical modeling that he's done for utility lines as well. As far as subterranean assets such as pipes or other elements, it's still best to model those inside of ArcScene on the Esri platform. Just extrude those in 3D based on attributes for width from the city's data if they have those. And You can also just superimpose those using your LiDAR heights. Give it a height from the LiDAR if heights don't exist, and give it a negative height, for instance.
But I have seen it displayed and visualized in CityEngine. Underground utilities.
Yep. So another question, I had another question from Bauman concerning in CityEngine 2013, I can export the geodatabase each feature per leaf. Could you explain what you're referring to per leaf a little bit further? Shannon, do you have any clue what that's responding to?
No.
So another question, are the rules we apply to different features designed to match only American designs? So Christina, great question. No, they're not. Initially, we started to develop them in that way that they had to be based off of Redlands, California, those building rules, but you can customize those, adapt those. Any of the key components in those rules can be customized to meet the needs of your city. And with that new building rule library, you're going to see that further and further integrated into these planning and urban design rules as well as having reporting based on those in the design process.
Yeah, and you can see examples of it on the website that we have for all the different CityEngine examples. There's scenes for Roman cities or medieval cities, or a lot of different variations. Mm-hmm. And Smarter, Better Cities, another business partner of ours, is designing building rule sets for different countries, because we recognize that there's different cultural values and cultural design types. And one of the examples I showed of Tohoku in Japan, all of those buildings that their Smarter, Better Cities built are Japanese-centric. It's the style and the shape and how they look are all culturally sensitive to the design standards there.
So, great question again, and another key group to think about for customizing these. If you're a planning firm and you need a third party to model these, Bergman Associates, some of the examples they made for Rochester, they can customize those based on your city. Also, Critigen can also, potentially based on your use case, help to model other building forms as well and help to build, I guess, CityEngine rules, or help to customize those to fit your firm's workflow or your organization's workflow as well. Esri may as well, but I'm not sure where we stand as far as doing that internally for third parties. So a couple other questions. Will there be NAE training courses in the future regarding CGA rule writing? We're going to be developing some more rules on CGA rule writing. If you actually go to the Resource Center, you'll see a lot of resources on showing you how to write these rules. Now, CGA rules are a little bit difficult, and that's why we recommend to use the rules that we already have, or read or open up the rules that we've written and kind of see how we've written those. It doesn't make sense to start from the ground up. Just like any other codes, if you're a programmer, use GitHub, you can reference existing codes that other people have written to save you hours, months, even years of time.
Well, we are working on some courses for CityEngine. One of the first ones, and I forget what you call them, Jeff. They're the small, like 4-hour courses. Mm-hmm. One is on our virtual campus right now, and then we're going to continue to build those out one at a time, and then those are all rather basic level, getting started type of level. Mm-hmm. But the next ones will be we'll dive into writing rules. So we're trying to do like maybe 3 different levels of courses, from a basic to intermediate to then advanced. It's going to take some time for us to build, but it's on the drawing boards.
So, I mean, that's Esri bridging into 3D for you, taking that third dimension and bridging into all these complexities of planning and urban design, which if you guys are involved with those industries, you know that they're not easy to work with. So it does take a little bit of time. So let's do a couple more questions. We're going to have to roll out here pretty soon. I think we're about 10 minutes over, but I wanted to make sure that everyone had their questions answered, and we provide you as much information as possible on what you can accomplish with CityEngine. Are there any plans to enhance documentation with more real-world examples? That's another great question, and yes, that example that you saw of Raleigh, I'm going to be trying to get that leverage to put into a training. We're going to be trying to get other examples, one from Smarter, Better Cities that you guys will be able to access as an example, and then other ones from other cities that we're working with in 3D. to show you kind of how we created these cities. So you can create whole cities, small areas, the existing conditions, and then you'll be able to see how we develop master plans as well with the rules applied to buildings or footprints or trees or even areas where parks should be. So another question, this one's from Esri, Romania. There's an intern asking a question on this. It's a historical city and a cultural city. Should I create rules by myself, or can I download rule packages and then model them? There's a few approaches to doing this. What I would first recommend using, and you can contact me directly, if anybody would like some of our most recent rules on creating existing conditions, just shoot me an email. I'll also send those out after this webinar as well within a certain time frame. You can leverage rules that you saw, for instance, for the city of Raleigh to create the existing conditions there and create their trees in 3D. But then also I recommend downloading some of the newer rules for buildings that we've just released in CityEngine 2014, and they come actually with the package by default. And you can leverage these to be successful and use these to create your buildings in 3D from that. Some other cool things is that you can go and take photo inventories and just place those on the side of the buildings manually by collapsing buildings after you've made them procedurally, or you can model them by hand with the multi-patch editor, or you can add them into those folder directories where it calls to based on the usage or information of your GIS data. So it's up to how you want to approach it. So if you have further questions on that, you could definitely shoot me an email or just get me contacted at Esri, and I'll definitely would like to discuss that further. I guess that's pretty much it for the questions we have today. Again, thanks everyone for joining. If you have more questions on geodesign or CityEngine, feel free to contact either one of us. And we look forward to seeing you at our next webinar here in a couple more months. Thank you.
Thank you.